Oh man, I genuinely don't remember how this works. And I probably never will, because I am freaking stupid. I guess I can check my phone. I don't know if it's cooking or not. Oh yeah, no, it's going. All right. It's that was a jump scare. My PFPs. Ugh, I need to change it. It's terrible. But more or less, I mean, you read the title, right? Uh, and I, as a proficient, you know, C++ user, am intentionally torturing myself to do this in Rust, because it's been who knows how many years I don't know the language. So, more or less, this is where I'm at. These are skeleton layouts just to like figure out how I'm gonna do the address buses, because there's multiple within this. It's badly designed, whatever. Someone's gonna get mad at me for saying that. uh, yeah, basically figure out MMIO, figure out address bus layout, struct hierarchy, whatever. And then there's this, which is like the bulk of what's actually going on. And then cart is, I mean, you know what cart is, it's cart. I have the most basic rudimentary NROM 0, so that'll support Super Mario, it'll support your Donkey Kong, whatever. Yeah, I mean, more or less that's the deal. I am striving for, at least with the processor, I am striving for clock cycle accuracy, if not very extremely ridiculously close to clock cycle accuracy. I guess to sort of show you the approach here, I mean, anybody familiar with the MOS 6502 knows what this is. It's your register set exposed over the ISA. You got some internal junk, and then you have, you know, your lookup table of instructions. And an instruction is just a vector of micro operations, and a micro operation is something you run once per clock cycle, right? So what is everything I'm doing in this file here? I mean, not much, right? You have registers, you have some helpers to get and set flags, whatever. What does step do? It just kind of executes a micro op, moves on at a high level, reset, whatever. Set flags, update flags, whatever. Update registers, just helpers. And then the actual instruction logic is in this file, where I'm basically, I mean, I don't really want to call it a compiler or an assembler, but what I'm essentially doing is, you know, where do I actually initialize it? Yeah, right here. I use a fancy lambda. If these are called lambdas in Rust, who knows? To, you know, instr new, and then instr new just does like a lengthy decode and compiles, hence why I'm trying to sort of imply compiler here, compile a list of micro operations that are used for the instruction. And yeah, that's more or less where I'm at. I am pretty far along with the CPU implementation, actually. So it's like all these opcodes are I'm kind of splitting things into. This is a very good doc, by the way. This link. If anybody's watching this and trying to do emulator stuff for NES, obviously this is a great link. But basically, I'm kind of thinking things in terms of ALU operation preceded by, potentially followed by, stuff that does addressing. So, or and then you have indirect addressing, you have immediate, you have zero page, whatever. So, enum for the ALU op, enum for the, not the inster, enum for the addressing modes. And then you can reuse a lot of the logic. Yeah, so not all of these are actually implemented. You can see I have absolute, XY, indirect, and I'm also missing implied or accumulator based addressing, and that kind of depends on, I don't know, it's a weird edge case for those. I'm probably just going to implement these one-off, because having the sort of reusable logic is probably going to complicate things more than anything for those weird sets of instructions. But yeah, I have probably written, aside from this project, no more than 1,000 lines of Rust in my entire life. So if what I'm doing is absolutely horrendous, please make fun of it. If my comment section is enabled. But yeah, right now the goal is these two, right? Absolute addressing modes with operations. So you could do like an absolute X followed by an OR. So you'd OR the accumulator with the byte read from an immediate address followed by, plus some offset or whatever. So yeah, that's the deal. That is the deal. Yeah, so I'm gonna just keep chugging along. Okay. So, I guess to give like a high-level overview of exactly how this works. Absolute indexed addressing. And you have different categories of these kinds of instructions where the reusable logic helps, where you can reuse addressing modes and ALU operations. So you have read instructions, read, modify, write instructions, you have plain write instructions. So for a read instruction, so each of these would count as an opcode, right? Or not an opcode, but a micro op, right? So fetch low byte. You can see I do that here. Granted, this is indexed, absolute indexed, and I'll just start writing absolute X. What the heck? Alright, so the first step is these will always fetch low byte increment PC, fetch low byte increment PC, fetch low byte increment PC, right? So micro ops push, micro op fetch absolute low, and the very fact that this says fetch implies that I will also increment the PC. That's just some internal terminology I'm using, right? So yada yada yada, fetch low, you read some junk, increment program counter. Rust is annoying, it doesn't let you do doesn't like integer overflow. I guess if you're gonna go giga autism on safety, that's a good thing, but yada yada yada, set low, right? And then this is the effective address that is being either read to or written from on the CPU bus, or main bus, the one that isn't the graphics stuff. Right, so now there's fetch high and add index register to low, increment PC. So this is something I don't actually have yet, I don't think. Yeah, because you have X. You have to add an index, so. I'll do fetch absolute high, add X. And then obviously this thing will complain. Okay. And then I think the way I'm going to do this, the tricky part is, like, you read the low byte, you read the high byte, addresses are 16 bits, and the address bus is byte addressable. So you read 2 bytes, you have an address in some temporary register or whatever, and then read from effective address. The problem is when you add X to the low byte, it can overflow into the high byte. So if I read from effective address, it's kind of funky because it can overflow. But when that happens, you might need, okay, here's an example. You might need an additional clock cycle, so that's where things are kind of, they become a massive pain in the rear to deal with. It's just edge case, crazy edge cases. I don't know, fix. Fix effective address. And then, so we don't even have an effective address. We need a way to track. And then this is probably complaining. Self temp. Okay. Adder fix, sure. Right, so straightforward enough. And then, let's see. Why is this complaining? Oh yeah, because as U16. I will say, writing this instead of, what the heck? You know, in C++ you have, oh gosh. In C++ you have this nasty static cast syntax, and it's terrible, and it's a pain to write. This is the old Game Boy Color emulator. I switched projects here in case that wasn't obvious. That's why I moved my terminal to another screen. But this, anyway, point is this syntax is absolutely horrendous, and I hate it. with every fiber of my being. This is like, I will say this is a massive step up. This is huge. It's really nice. So anyway, that gives us the fixed address, but that doesn't set the effective. Set low. So I mean, we add X to the low byte without doing anything to the high. So, oh. We just do CPU. Adder fixed and did that low byte. And then I don't know. As U8. Right. So you can see where the sort of dilemma is. You have a high byte that doesn't match what it should be because the low overflows into the high, but only you can only update one thing per instruction, I guess, or not instruction, the opcode, not opcode, I'm retarded, micro op per clock cycle. I'll say micro op and clock cycle interchangeably. Read effective address. So that gives us this logic. Yeah, so now this is where things turn into a massive pain because we have to do this logic, and if this isn't, and they don't tell you, but if you're doing an ALU op like an OR, that also happens on this clock cycle unless the page boundary is crossed. So if the page boundary is crossed, problems, right? You read from the wrong address, and you have to redo it. So, yeah. And I've made multiple attempts and kind of came up with like this hacky junk that I really don't like, so I'm probably gonna refactor this. I'll be back. Bathroom. Alrighty. So, yeah, I want to get rid of this because it's terrible. So basically, if you have an ALU operation, you know what? I don't even want to give an explanation because I don't really know what I was thinking. This is just bad. Maybe it's bad. I don't know yet. Hard to say. So I guess the way we could do this is we could determine here Yeah, I don't know if it's gonna backfire later though. Yeah, it's tricky because I don't want to bloat the vector up with unnecessary junk and double increment the index to skip over. That's hacky. I don't know. What the heck? So I mean, I guess we could do. So it's like the way I'm thinking about it is with the default control flow, you fetch the low byte, you fetch the high byte, add the index, and then do the ALU operation, and then that's it, in most cases. If not, this overflows, you screw up the high byte, and then if you screw up the high byte, let's see, if you screw up the high byte, if you screw up the high byte, you want to not, do the ALU up, and then just refetch. So that's kind of what I'm thinking with this retry, is if this explodes, you need to redo this junk twice. So if it screws up, skip the opcode, just retry that micro op. I mean, kind of forces me to keep this hacky thing, but whatever. So this is going to return nothing. So what? No way I get this right first try. Whatever. So then, yeah, we read whatever, and then that is going to need this to return a boolean. Okay, sorry, someone walked in. So yeah, this returns a boolean now. Yeah, whatever. What is this? So I guess, I mean, this is always going to be the same. So let's see, this is always going to return false. Because, like, immediates don't cross page boundaries. It just doesn't happen. And then this is, I don't even know what the heck this is, but we'll assume false. Just not worry about the page boundary screwy thing. So return whatever we read from the effective address. Just read whatever. And then I don't know, CPU address fix not equal or something. Right, so if these don't match, we need to retry because the high byte is not correct. I mean, I guess if I was really mature, I would actually check the high byte, but I mean, this will probably do. This is probably sufficient, whatever. So that is probably going to cause a bunch of errors here. Let's see. See, is that an appropriate name? It returns true if we mismatch, yeah. Why are you... Oh, duh. Okay, this one's fine. I don't have to mess with that. These are still screwy. I'll fix those later. Whatever. It's that. And then, okay, so now we actually have to do the delay. Let's see, does this return... That returns nothing good. So I guess we can just kind of... If delay we want it to retry. Shoot. I don't know. It's not necessarily like the cleanest, but eh. That's fine. Let's do a proof of concept here. Just want to make sure that this doesn't completely screw me here. Yeah, okay. I just want to make sure it builds. I didn't miss something ridiculous. That's fine. Editor mode. Okay. So we're here. Fetch low byte increment PC. Right? That happens. So we're doing this guy. No, we're doing this guy. Oh, okay. Not quite there yet. So I would need to do add X. Sure, whatever. So for read operations, am I thinking straight here? For read operations, we do right fetch low byte increment PC. This fetches the low byte and increments the PC. This thing fetch high, add index register to low byte increment PC. And again, I also need to track. Make sure this isn't getting nuked. So yep, there we're checking. Is it getting nuked? We're tracking what it should be, so that we can know if it's getting nuked. I should not be saying that. It's very bad language. Insensitive language given the times. We don't want this to be you know what I mean, man. Page boundary crossed. Whatever. And then ALU push off. So that would do and pull ALU up and then or a what? Or a there we go. So that'll try to so now we're doing this, right? Read from effective address. So whatever the heck is in here. Shoot. Whatever is in here. Right, we're doing absolute X addressing. We read the byte, whatever's in our effective address. If it doesn't match the fixed, we return true. That's going to cause this to retry. Fix the effective address and retry. And don't do the LU op. We're going to fix the high byte. Yep, so that's what this should be doing. That sets this to what it needs to be. Whatever. And retry. Yeah, so by decreasing this step, we essentially repeat this micro op. It's probably fine. And then if it needs it, so if it doesn't need it, it'll do update, right? And then if it does need it, it will do this, then update on the next clock cycle. Fine. I can live with that. I guess. So now the question is, how do I do writes? Because I can't really reuse this for writes. Writes are kind of stupid. Because notice how this is, they have a plus. It's like this only happens under certain conditions. With this for writes and read modify writes, it just kind of happens unconditionally. Right, there's a, so let's follow the workflow as is. Like, how does it, let's pick a good write instruction, stx. I guess I say store x so I can reuse it. Right, so we just do plain bus write byte x register. Oh, I can't type store x. Okay. So, and then if I'm doing addressing mode, I'm doing absolute x, whatever the heck. Absolute x. We fetch the low, then we fetch the high and add the x thing. So that does this, and then this, and I don't think this ended up doing any weird conditional nonsense. Yeah, no, this just does it unconditionally. Good. So this is perfectly fine. Then we read from effective address, fix the high. So this we don't have. And this is where things become problematic, because no ALU op happens here, as far as I know. So we read it, then we read from effective address, write the value back to effective address. Alright, so this is why it's tricky, is because previously for reads you could like combine this into a single one, and this would just be kind of not non-deterministic, but it would only happen under certain, you know, when it's needed. Save the clock cycle. I guess I didn't do it here, whatever. Let me make sure that that's not like a, this is remodify right, so we could use ASL. Oh, I'm stupid. ASL absolute. Shut up. Accumulator, I don't care. Absolute. 6. Does that make sense? 6. No, that does not. Oh, absolute x. Okay, 7. Okay, that makes sense. It should take 7, and it's 7 unconditionally. Okay, so I'm probably gonna need an extra micro op for this guy. Read from effective address, fix a high byte of effective address. Read from effective address. So I think this I can use. I just get rid of that. It's misleading. Ugh, my Vim is lacking. Norm, find that, bang. Yeah, so I can use this for this clock cycle. And then read from effective address, fix high byte. Okay, and this is nice because I have this, and the retry is optional, so that's cool. Alrighty. So I mean, I guess we'll do no. Sure. Stupid. CV temp plus read byte. So that gets the effective, and then we'll just kind of sure. So that's that, and then we can follow it by this to get the correct thing for the ALU op. So now the question is where to insert these into the list. Salute X. Right, so I mean, I guess I could do it. See, it sucks. I can't just insert them here, and the reason being is because for read that doesn't happen. For read it does this weird hybrid. Right, we do this and then we do this. Similarly, we do this and we do this. But then the behavior differs, so this is only going to happen for read. This behavior is embedded into the ALU op itself, where it'll retry if it doesn't get the right thing. Whether or not this is true on hardware, I don't know. This is my implementation. And then this is for read write modify. And then this is for write. So tricky. Yeah, there's a weird okay. And we got push ups. So I want this thing. Might make one of these wrappers for write. Because for STX, let's focus on stores for now. Like just plain writes because they're easy. Low byte, we do that. High byte, add the thing, we do that. Read from effective address. We don't do that, and this is necessary to prevent, you know, I mean, I guess they flip the read-write direction to write on this cycle so that you can write here, and then it also prevents the page boundary crossing from being stupid. So this needs to get introduced. Does it? It does. And then, yeah, for read modify write it doesn't, because it happens here. Read from effective address, that would correspond to this guy. Somehow this is already here. That's crazy. I do not remember writing that. That is, I might have frickin' brain rot. I don't remember writing that. Okay. So if we're doing a write instruction, I mean, I guess let's get the obvious part out of the way. These are all gonna be S. Oh, this might be crazy. Bruh. Stupid. And then I need to pass self. The micro op. Oh, that is the micro op. I'm brain dead. Addressing mode. And that. Sure. Okay, so if we're doing a write, I have to read from the effective address, and I can just kind of toss it. Right, so I can do what else? So we have to we have to write, and then we have to so we can just kind of micro-ops push, and then what the heck am I using? So there's that. What is this? Micro-ops push. Micro-ops push. So I would be pushing this, which is going to read and then fix the high byte. So that would be ALU up, not ALU up, micro up. That'd be, oh gosh, that'd be this, I think, because that reads into temp. I don't think fetching into that's gonna be a problem. So we would do this followed by this. Okay, so it takes the source from the register, or this, and I guess it's fine. I mean, it might be problematic with read modify write, but we'll see. We'll see. I don't know. Push. What am I pushing? I'm pushing. Ooh, voice crack. I am 8 years old. Fix. Load temp fix. Sure. So it'll do this, it'll do this. This is introduced before the ALU op. I mean, I guess that works. So then, for these guys, kind of sucks. I might need. Oh, duh, I can do it here. Stupid. Except I'm not passing the address mode in. Oh, that's ugly. Whatever. So let's see, I have to do. Let's see, does it hate that? Does it hate that? Yeah, you can tell I've been struggling with my internet a bit. Anyway, what was I doing? Cargo run. Okay, that builds, whatever. Shoot. What am I doing? Address mode. Yeah, okay. No, this is good. This is good, because now I can do a match. I mean, essentially just this. Bang. Probably just the same thing. Yeah, screw this comment, who cares? No one's gonna read this. Okay, so then the workflow for for read modify write is we'll do this and this by doing fetch absolute low, fetch absolute high at x. Right, index register refers to x, that's good. And then I'm looking at right because I'm an idiot. Fetch low, do this junk, fetch high, do this junk. Alright, so that's that and that. And then read from effective address, fix the high byte. So that should happen here now, right? Read from effective address, that's load temp, fix address, that's unconditional. And then we read from effective address, ALU up store. Read from effective address. Okay, so the writing the value back to the effective address is part of the ALU up. Again, the sort of whatever. It's kind of weird. And then store. I mean, I guess, man. Or sorry. Is that correct? Right, because if I do let's look at like ASL or LSR or whatever. Yeah, okay, we do the right here, so that's fine. I am going to have to get off for a short period of time. But I don't know, I might get back on and keep streaming. We'll see. But yeah, so it's kind of weird. It's like, there's probably, I mean, maybe if anybody ever ends up watching this, there's probably, to the attentive eye, they're probably thinking, why would you need to write here? It's like there's no reason to write here. You're just doing an LSR. And that's true. It's not strictly necessary, but technically the processor does do either a read or a write every single clock cycle. So it'll just do whatever the heck is there prior to doing the ALU up on it, right? So you notice, write the value back to effective address. That's whatever we read in this step, right? You can see that this will come from the same source. That'll come from load temp, right? Load temp, when we do the ALU op, right? So we store whatever that value is back, in the effective address, then write the value. Okay, then do operation. So then we do the LSR, and then there's an extra write to write it back again after the ALU op completes. So it's a mess. There's a lot of whatever, man. Yeah. Sure. I mean, I guess this is probably correct enough. Anyway, wow, an hour to do a single addressing mode. Help. No, just kidding. I mean, I guess it wouldn't be hard to do Y after this. I'm gonna do it probably, a pretty crappy way for now. That being literally just taking this, doing that. This is gonna complain. Bang, bang. And then X needs to be there. And I mean, like, yeah, bad programming practices, you could just pass an enum in and not do this duplication nonsense, but I'm in a rush, and genuinely don't care, so. Yo. And that gives me That gives me that. And that should work for... Okay, so there is like a kind of a crazy thing I've been maintaining. Let me pull it up. This paint. I'm not gonna open GIMP. But... Oh, I hate that. Freaking jump scare. My gosh. It's not funny. I haven't used this website with headphones on yet, so that was terrifying. But anyway. So it should give me absolute... Did I mark it already? Shoot. I might be stupid. This isn't my first attempt trying to get it working, so I might have updated it at one point and then reset it. And updated this picture in between attempts, but it's basically just I'm doing this to keep track of how much I have left. So I don't know, or a absolute X. So if I've cleaned this column out, okay, yeah, this is where we're at then. So next, I will be fixing bang 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 because I have to do these two addressing modes, right? So it'll take care of bang, bang, bang. And again, I already have the ALU operations implemented, so all I have to do is the addressing mode. These are implied, so I'm waiting on those. These are implied, I'm waiting on those. And then this, I'm going to handle separately. So, that is where we're at. Yeah. I don't know. I don't know. Maybe there's a more intelligent way to handle jumps. It's like I could take advantage of the fact that... We'll see. I don't know, man. I'm also not considering relative addressing yet. It's kind of a pain. I don't even think this doc relative. It does talk about relative addressing. Okay. Yeah, I'll have to do some prerequisite reading because I don't know how exactly. How many of these are legal? BCS, BCC, BV. Okay. Yeah, I'm glad I'm reading this because this is gonna be like a pretty pivotal thing to not butcher. I do not want to do that 50 times over. Cool. Review this. Let's see, so yep, this does an unconditional, just messes with that low byte. This does the same thing. And then prior to the ALU op, if we're doing either of these, we try, no, we don't try, we do fix it. We guarantee that it's fixed. We guarantee that it's fixed. So that's correct. And then yada yada yada. Did some cleanup there. What is this? Address mode, absolute X. What is this? This is a match on. I see. So this is for read specifically. So if this explodes, this returns false. This returns true. And then we handle it in the ALU op itself. Retry it. Oh, I think it's kind of hacky, but I think it's reasonable given that on the clock cycle you would expect to you would normally expect it to do the ALU op. It may or may not. I think it's reasonable. And then I guess also Let's make sure this is, yeah, that decrements it. So I actually haven't thought that out very well. So if this happens, and I have my step here, stepper, not that, step. So it would do the micro op here. That would decrease, yeah, okay, that's fine. Because it would get decreased here, then it would get re-increased, and then would just redo it, fine. Again, I'm like, there's something about this that just, I can't help but think this hurts people's eyes. Because I just don't know Rust, so if this is like a piece of junk, and I need to use better syntax sugar, please roast it in the comments if anybody watches this ever and has half a clue what they're saying about Rust, because I certainly don't. Absolute X and Y. Cool. I will end it there, and again, probably do more later.